Hey, what's up AI Nation? This is Joe Papa, founder of Teach Me AI, and in this video I'm going to give you a quick Python and Colab crash course / review. Right? So what I'd like to do in is about 5 minutes tell you everything that you need to know about Python and Colab. So if you're going to plan to take one of our courses, AI for developers, we have about 10 courses that we offer there. This is a great video to brush up on Python so that when you come into the course you're ready to go. So let's jump into it. We use Google Colab for almost everything that we do. You can just, if you have a free Google account, you can use that. If not, sign up for one and go to Drive. That's at drive.google.com. You'll see a screen just like this one. This is my Drive here. So we're going to go to New and go to More. And there's something that says Google Colaboratory. We're going to click on that. That will open this new document. Now, if you're familiar with Jupyter Notebooks, this is very similar, very similar platform here. Allows us to write code in these cells, and then we can hit Shift Enter, and that will execute our code. Now, this is all for Python. Okay, it's all run in the cloud. Our interface here is in a browser, but it's run on a cloud CPU. There's also GPU support, which is why I love to use Colab, and we'll show you that at the end of this video. But basically you have a document here, and like all Google Docs, you can share them, you can collaborate on them. It's a really awesome tool. So the first thing we want to do is change the name of the file. So we'll call it Python Colab Review, and I'll call it DYI. Alright, you just hit enter, and there you go. So now to write the Python code, you just write in the cell. So the first thing you want to know with Python code is how to import libraries. And one of the libraries that we use very often is PyTorch. And you can import that with just import torch. I'm going to maybe just increase this a little bit here so you can see it better on your screen. Alright, there's a couple other ways that you could do. Some of the ways we use if we just want to import a submodule of this library. We can do it in a different way using from, and here we're going to import from the torch library. We're going to import a module called NN for neural networks. Now that's one way to do it. There's another way to do it, right, which is called import torch.nn as NN. Now I prefer the first method for a number of reasons. If you look at some of the Google coding standards and guidelines, they prefer it this way, but a lot of people use it in the second format to just simplify the namespace. It's all a namespace issued thing, which we won't get into now. But either one will work. So we can hit Shift Enter, and we'll see that this little swirly thing goes. That means the code's executing, and once it's finished, we'll have the libraries. Now we can go ahead and start writing code. Variables are easy. You don't have to predefine them. It's all dynamic typing. So you can write things like x equals 5, y equals 6. A cool little trick is you could actually use the idea of tuples to set 2 or more variables at once. So we could do something like this. We'll give you the same results. Okay. If we just put a variable on the last line, it'll automatically print it out for us. So let's hit Shift Enter, and we can see that x equals 5. If we want to suppress the output, we just put a semicolon at the end. Okay, and we won't get the output. Another way to do this is we can use the print function, and that will also print out the value here. Now what's cool is if you mouse over, you can also see the values. Here it'll show you, and there's a lot of neat tricks in Colab, and I'll get to those in just a minute. You can see what type this variable is by using the type method. You can see it's an integer, and there's many different types in Python. We're not going to go too far details here, but it does support things like lists and dictionaries, which are very useful when we're programming. But right now we'll just stick to integers. I'll leave that to you on your own to explore the different data types in Python. So the next thing I want to show you is how do you write a function in Python. We use the def keyword here. So let's create a function called add and multiply by 2. So this is going to add 2 numbers. We'll call them x and y. We'll actually call them something else because they don't have to be something we've already created. This is specific to the function. And then we use a colon here. Now we hit enter, and we see that we automatically tab the next line. Now that's important because in Python, white space matters, and these tabs matter for things like functions and for loops and if loops. So make sure you pay attention to that. All right, so we're not going to do much in this function. We can simply return 2 times a plus b, right? If we want to make it a little cleaner, we'll do something like that. So that's our function. We defined the function. Now if we want to use the function, we could do something like z equals mults by 2, and we could put in any values, right? So we could put 7, 8, or let's make it simple, 1 and 2, and hit shift enter. If we type z, we could see that it's 6, which is what we expect. If we add 1 to 2, we get 3, multiply it by 2, that's 6. So you don't have to set it to a variable, right? You could just use it like this, and you should get the same output. Works just as well. Okay, next thing I want to show you is classes, and this is where the power of Python really comes into play. So to create a class, we're going to create a class called network, and if you don't subclass it, you're just going to take it from the basic object class in Python. But here we're going to subclass something called module in the NN package included in PyTorch. So to do that, we've imported this earlier here, and we'll do that by doing this module. And what that does is it gives us all the features, all the functions and attributes associated with this parent class called module. And the basic idea behind object-oriented programming, if you're not familiar with it, is that you can build off existing classes by subclassing them. And the advantage of that is you get all the benefits of the parent class, but then you can add your own flavor to it and add different features and stuff. So you don't have to reinvent the wheel every time. You can leverage things that other people have created or things that you created in the past. So to do that, I just want to show you how to do that. You create a class here called net, and then we're going to add some methods or functions that are associated with this class. Now there's an important one called init, and it has these 2 underscores in the front and the end of it. Very important. We're going to use the self keyword. Now self replies to the object itself. So in other words, when you create an object, you're going to take this class, what we call net, and we're going to create a network from it, right? So when we create that, that's called object instantiation. When we create a model or a network, we can build it off of this class, which basically has a set definition. It has some attributes or variables that are associated with it. It also has methods, which are functions that you can perform on that object. Okay, so you'll see more in a minute, but this self keyword here is very important because it refers to the object itself. Okay, if we want to add input parameters here, we can do so. I'll show you an example. We're going to use the input parameter called input size, and by default I want to set that equal to 1. All right, you don't need to set a default, but it's good practice. So then we're going to add our colon again. Here's another very important function when you're subclassing. It's called super, and what that does is it executes the initialization routine of the master class. Now I'm not going to get into too much detail on that, but just know that you should do it when you're subclassing things in Python. Okay, and this is the format here we call super. We're going to pass in the name of our class. We want to include the self variable for the object we're creating, and then we're going to call the method associated with the master class here, and then module. So anything that's in the parent class would get initialized during this call. Alright, so the next thing we want to do in the init program or init function is we want to create our own attributes or variables that are going to be associated with this object. So the first one we're going to create is called layer, and we do that by using the self keyword and then self.layer, and we're going to use our NN package here, and we're going to use a layer called linear layer. Very simple. And we can see that as we're typing these things in Colab, it'll show the help features here, the doc strings, so that you can easily see what the parameters are when you're using things like methods and functions. So here we can see that the first parameter is the number of input features, second parameter is the number of output features, and the rest of them are all going to be used for defaults. So for input, the number of inputs, we'll use our variable here. Now we could use we're going to use input underscore size, which is the value that we're initializing the object with, and then for output we'll just use 1. Alright, now we can also store the input size with the object. If we want to do that, we do that with self.input size, and you can call it anything, but we can set it to the variable that's being passed in. Alright, so that's a simple version of how to build the initialization method for your class. For this particular class, networks, there's also an important function, and this is something specific to NN module, but we also need to define something we called forward, and this is all required by this in order to subclass. So we're going to pass in self, and then we'll also take in an input called x in this function or method, and then simply we're just going to call the layer that we defined above and pass it in that value and then return x. Now we could have just put return here, right? But we'll do it this way this time. Okay, so that's it. That's how you create a class. So we've defined an initialization routine. We defined two attributes actually for this class, one called layer, one called input size, and then we also defined a second method called forward, which we can call as part of that object. So now the next step is to instantiate this object. So we'll call it model, and you just simply call the class like this. Now if we just enter it just like this with no input parameters, it'll use the default input size 1. But let's set this to like 10. So we're going to use the input size equals 10, and you can just put in 10, or if you're going to do things out of order, I mean, we only have 1 here, you can also do it this way as well. Either way will work. Okay, so that's how we instantiate our model. So let's go ahead and execute that. Now we can see, if we look at the object, now we have an object called model, and we could do another one if we want, right? We could do another object and put, let's just do the default here, right? So we have model 2 and model 1. So now we have 2 models, objects that have been built off the net class, and we can now use those. So if we simply use the dot here, we can see all of the associated attributes and methods associated with this object. Now obviously we didn't program all these things in our class here, but what we did do was we subclassed from the NN module. So all the ones that we see here as suggestions are coming from that parent class. Okay, so let's take a look. We can access the attribute called input size, and that will return, right? If we look at the other object we created, we can see that it's 1. Right? Now if we wanted to execute the method or the function associated with that, we can also call forward directly and pass in a value. Now here's where things get a little tricky, because in for this particular parent class and in module, it expects a certain data type for an input. So before we do this, we're actually going to set that input. So the input to this, we need this to be a tensor, right? And that's a special data type in PyTorch, which basically represents a multi-dimensional array of numbers. So we're going to create a tensor, and so we're using the torch package here that we imported before. There's a method called tensor inside that package, so we use the dot operator here, and then we pass it in a value of 2.0. Alright, so we're expecting a float, that's why we use 2.0, and you could also do it this way too, that'll work fine without the 0. And then we're also going to chain this by calling another method called unsqueeze. And what this does, real quick, we don't need to cover too depth in this video, but what this is doing is it's adding another dimension to this array, because these neural networks expect things to come in batches. Okay, so just think of this as an example of, we're going to create a data type here, a piece of data. It's going to be a PyTorch tensor, and we're going to unsqueeze it using this function. So let's go ahead and do that, and we can see that we do have a tensor here. If we mouse over it, we can see it's of type tensor, it's of size 1 with shape size 1. There's a lot of information that we can see here. Alright, so now we're ready to pass this in. Let's use model 2 because it has an input size of 1, and then we'll use our input here. Actually, we're going to use the forward method first. So this is how you use a method and input, and we can see that we get an output here, which is also a tensor. Now for this special class and in module, we actually don't have to call the forward function. It's done by default for us. Now this is not a Python-wide thing. This is just specific to this NN module parent class. This is really the Python method or Python way to access a method of a class, right? So if you're not following all this, it's okay. I just want you to get familiar with object-oriented programming, how you do it in Python. We're pretty much done here. I'm going to show you a couple things to finish up, and this is taking way longer than 5 minutes, but hopefully, you know, we could get this done in about 10 minutes. Let's see. So the next thing I want to show you is just, because this is a special class and a module, we don't have to call the forward function. We can just pass in the input, and we get the same answer. Okay, so two more things I want to show you, a couple more things I want to show you, and this is really all you need to know about Python and Colab. Like, we're going to cover this in just like, 10-15 minutes, less than 10-15 minutes. We'll cover all this, and this is really all you need to know to take any of the programming courses that we do here at Teach Me AI. So I want to show you how to do a for loop in Python. It's simply for, use that keyword. Let's do I in, and we could do range. So that means that we're going to use the iterator here of range 1 through 5, and then we can print I, and we'll see how that works, right? So it actually goes from 0 to 1, 2, 3, and 4. Starting at 0, and we can see that's how you do a for loop. Remember, you got an indent here, which is done automatically for you in Colab and most IDEs as well. Now let me show you how to do an if statement that's used a lot here. So we can do it simply using if I less than 2. Remember, use a colon, automatically tabs for you. We can say print yes. If you want to do else, just go back and do else colon print no. Okay, and that's it, and then it says no. Okay, now there's a short way to do this, which is really cool in Python. You can just state the output here. So let's say print yes if I is less than 2, else print no. Okay, so that's a short 1-line statement, so we compress 4 lines that we did in the above cell into just 1 line here, and we get the same answer. All right, nice little shorthand. And that's all you need to know about Python. We covered all of Python here just in a matter of a few minutes. And let me go through some of the features of Colab real quick, because this is one of the most powerful tools that you can get for free. I'm using the Pro version here, which gives you a little extra time and a little extra space, but really the free version should be sufficient for most cases. Okay, so you can see that we can mouse over things, right? We mouse over our variables, we get the information, but over here there's a variable window here, and you can click on this little X in curly brackets, and you can see that if you want to debug, you can see what the values are, the sizes are, the types of your variables here, and so on. So we can see that our objects here are type net. We can see the integers, we have our tensor, and so forth. Okay, to close that, you just click on it again. One thing I want to show you here, you can also add text to this. So if you want to add text, you just press this, or you can press this, and it will add a text cell, which is pretty neat because you can create some text for your document. So let's see how to load a file. Alright, so we could add some text. Now I'm going to show you how to add a file, and I'm just gonna copy some code here because it's a lot to type in. But what happens here in Colab is you have a cloud instance, right? So when you start this document, it's running in the cloud on Google Server somewhere. Okay, your file store is not local. Your file store is also in the cloud. Now keep in mind, if you close this window or you close the instance or you wait too long, it'll stop the instance. You're going to lose all your files. You're going to lose the state of your virtual machine here. So be wary of that. If you want to see the files that you have, you click on this this little folder icon here, and it probably looks similar to what mine looks like. I'm going to show you how to download a file from the internet using urlib, which is a library. So we just set the URL and use this URL retrieve function, and so you can shift enter this, and then you can see if you refresh this over here, you can see that this file is now in our local storage or in our cloud storage, and we can use this. We can read this file, we can print, display it, manipulate it, whatever. It's all available to us. You can also upload files by using this, and this will kind of open up your local window. You could link it to Google Drive if you have files in the cloud and so forth. Really powerful. Here's a little code snippet stuff, which is a lot of just, you can insert things for input. There's a lot of neat stuff there. I'm not going to go into this right now. This is if you want to search for commands, very powerful tool. And then you could even get a console here. I'm not going to bring it up, but it's there, it's available. Okay, so here's where file, you can save copies in Drive, you can save a copy in GitHub, keep track of your revision history using the tool here, download things, print them, etc. All right, there's editing stuff is pretty straightforward, as well as view, insert. Runtime is important. So your cloud instance, you have a runtime running, and if you need to restart it, you can restart it. But one thing that we use very often here is if you want to use a GPU, and this is a powerful thing about Colab, is it does support GPUs for speeding up training of neural networks, etc. Is you just go here and you change the accelerator to GPU. Pretty cool. You could also use a TPU, which is a Google chip tensor processing unit, similar to a GPU, but works a little bit differently, but also used to speed things up. Very, very awesome. So if you change this to GPU, it's going to restart your thing, and you can see here that it's restarting my runtime, connecting, initializing. Now we're all there. So we can see we lost our file, so we need to download that again. The state has been reset. So just be careful of that. You can see you can diff notebooks, which is sometimes very, very valuable as well. Here you can share with people, you can comment, much like other Google Docs, and then you have your status here. Very, very powerful tool, and it's all for free. The free version is really, really awesome. So check it out. It's just Google Google Colab, you'll find out more information about it. But that's it. That's all you need to know for Python. That's all you need to know for Colab. And now we're ready to tackle any detailed topic and learn how to program Python, learn to do deep learning, machine learning, and whatever you want to learn in Python, it's all available for you here. So hope to see you in the class soon. Again, I'm Joe Papa, founder of Teach Me AI. And until then, go out there and build something really cool. Hope to see you soon.